Hello and welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to discuss some of the concepts that you must know as far as paper 1 of physics of May-June exam is concerned. If you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. In this video, we're going to start by looking at as the most common topic, and you can see here this paper is 110 marks, so it's a very important paper for you to perform well in physics. As you perform better in paper 1, then paper 2 you do well, and then it means that the overall grade is going to be a good grade. So the first thing that you are provided with is some of the formulas which can enable you work out some of the equations. And you can see here we are given equation of motion, and this is mostly the equation of motion that is tested. And we are given also the constant you'll be using in the process of doing with gravitational field strength. We need to go straight to the first question. Question 1, I've tried to bring up the concept of motion graphs, and here we are having a distance time graph. So meaning that from a distance time graph you can be able to get distance covered by an object, and also if you work out the gradient of a distance time graph, you are able to get the speed of the object. You need also to be well prepared on how to answer questions to do with velocity time graph, and you need to remember the feature of a velocity time graph that enable you to work to get distance is the area under the graph. But the feature of a velocity time graph that enables you to get the acceleration of that particular object in question is the gradient of a velocity time graph. You need also to know different shapes of velocity time graphs in order to answer all possible questions that can be asked in that. So here we are told that a graph shows how distance traveled by an aeroplane changes during part of its journey, and then we can see here we are given distance in kilometers and also time is given in seconds. Let us see what is the question that they are asking us, because we are told here state the formula linking average speed, distance moved, and the time taken. So you can realize that this is one of the equations that is not given. So you have to know how to write the formula for average speed. Remember, another formula that is never given is the formula for density. So some of those formulas that are not given on the formula sheet, try to check them out. You know what you have to know and what is provided. So we need to go ahead and write the average speed is equals to total distance moved divided by the total time taken by the object. And in this case we can see it's actually 700 kilometers and the time is 60 minutes, which means that we can be able to work out the average speed in kilometer per hour. So I'm going to use the formula distance over time, that is now 700 divided by 1 hour, because 60 minutes is equivalent to 1 hour. So if I work it out, I'm getting my average speed is 700 kilometers per hour. We need to move to the next bit. So I mentioned that velocity time graph, if it's like that, it means acceleration is constant in that case. And also you need to remember that area under a graph of a velocity time graph is actually the distance covered by the object. We need to move down to another concept. In this case here, we are told during the flight, the height of the aeroplane decreases. As the height of the aeroplane decreases, the temperature outside the aeroplane increases. Now, explain how air pressure outside the airplane changes as the height of the airplane decreases. So if we are told that the pressure increases as the height decreases, this means that we are going to talk about the kinetic energy of the molecules or the gas particles. Remember, pressure of gases depends on the temperature around. So meaning that if you increase the temperature, then the kinetic energy of the molecules is going to increase, and this is going to result more collision per unit area, resulting to a larger force. So meaning that pressure is going to increase. So meaning that in this question we are going to respond by saying that increase in temperature result to an increase in the kinetic energy of the particles. All right. So we need to say that pressure outside increases, and we're going to give the reason as to why this increases is as a result of increase in temperature, which result to the increase in the kinetic energy, making the collision to collide more often, and this result to an increase in pressure. All right, moving to the next question. That this is energy stores. This is a question to show energy transfers or energy changes. So you are told that a beak of water cooling down, which energy store decrease. This is thermal energy, because if water is cooling down, meaning that the temperature is going to decrease, and this will mean that the thermal energy store of the water decreases. Since now this one is the one that was done for us, we need now to move down. A car moving horizontally and slowing down. What actually decreases here is what? Is the kinetic energy store that decreases. We are going to talk about a ball falling down for a ball falling towards the ground. This is gravitational potential energy store that decreases. What about nuclear splitting due to fission? This is nuclear energy, right? Nuclear energy. What about stretching a rubber band? Decreasing in length. This is elastic, right? So we need to move down to the next question. We are told that energy is transferred when a filament lamp is connected to a battery. Which method of energy transfer that takes place between the battery and the lamp? This is actually electrical, right? This is electrical. Next question. Which method of energy transfer takes place between the lamp and the surrounding? This is what? This is light radiation. The next question, we are told that the photograph shows International Space Station ISS in orbit around the Earth. The ISS orbits the Earth in a circular orbit. Which of these also orbit the Earth? We know the comet orbits a star. Mars is a planet which orbits a star. The moon, actually the moon orbits the Earth. The sun doesn't have its orbit, right? So that one we need to identify these guys. So this was a star, this was the sun, and the moon is the one that orbits the Earth. Which of these forces causes ISS rather to orbit the Earth? This is actually gravitational force. Air resistance is a force that you experience when you are moving or running on an open area where there is air. We have electrostatic, is a force that exists between positive and negative charges, and friction is a force that is experienced by two objects which are in contact to each other. The ISS completes one orbit of the Earth in a time period of 93 minutes. The orbital radius of the ISS is 6.8 times 10 raised to power 3. We are supposed to calculate the orbital speed of the ISS in kilometer per second. So you need to remember that the formula for orbital speed, we were given that formula, and I did mention that that formula was in the formula sheet, right? So let us try to see whether that formula, where that formula is and how it is stated. Let's go straight. Yeah, you can see that formula is somewhere here. All right, we are given a formula for electrical energy. We are given in waves, we are given a formula that relates frequency and period. Under work power and in work energy and power, we are given formulas there. And now we also have the formula for the orbital speed. And remember, now if this is an object that is orbiting this sun, then this object is going to move around the orbit in that particular direction, or the other way, whichever the way it's moving. But you have to know the period, the time period it takes for the orbit, for the object to orbit around you need to know the time it takes the object to go around once in the orbit, and that's the periodic time. You need also to know the radius of the orbit, so that you can be able to work out the orbital speed using that particular formula. All right, so we need to go straight. We need to go straight down so that we can be able to now work out that question, whereby we are supposed to work out the speed, the orbital speed of ISS. So let's go down and see what we are supposed to do there. All right, so let's go down. We are almost there. All right, if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. So we need to write the formula that you can be able to use in order to work out this particular question. And we say that the orbital speed is given by 2 pi r, where r is the radius of that particular orbit. And then we also know that the periodic time was provided in this particular question. So let's work it out. All right, so the reason as to why I've highlighted 93 minutes, we have to convert that minutes to seconds by multiplying to with 60. So if you work it out, you're going to get your answer close to, let's try to put this in our calculator, 7.66 kilometer per second as the orbital speed. Show that ISS completes approximately 15 orbits of the Earth each day. So which means that we are going to check how many hours do we have in a day. That is 24 hours. So it will be total times in a day divided by the time for one complete orbit. So that's going to be 24 times 60, so that we have our time in seconds, in minutes rather. And then we divide by 93 because it was taking it 93 minutes to make one complete orbit. So if you work it out, you get this is going to translate to 15.48, which is approximately 15 orbits. Question number 4. This question is about electric circuits, which is you are asked to state which quantity is defined as the rate of flow of charge. Actually, this is current. Because power is the rate at which energy is transferred or the rate of doing work. Resistance is voltage over current, and voltage is the work done to transfer charge. So which quantity is defined as the energy transferred per unit charge passed? So this is actually going to be voltage. So the first one is going to be current, and the second question is going to be voltage, right? Then we move to the next bit. Of course, I'm just writing that so that you will be able to remember, because as we are going through these questions, it doesn't mean these are the only question, these are the questions that will be asked. You have to be multidimensional as much as you are preparing for your upcoming exams. These materials are meant to support you and also to supplement other materials that you have to couple with your revision program. All right, in the diagram shows an electric circuit with two resistors R and S. Some of the values for the current are also shown. So we need to remember that when current reaches a junction, it divides. It divides. So this, if we were having 0.60 amperes moving through the circuit from that end, when this current reaches this junction here, is going to subdivide into 0.4 and 0.2. Then this current, when it joins on this other end, it becomes actually 0.6, the one that was there. So we realize when you have two resistors, it's going to split the current into two parts. So what you need to remember, what is the same between R and S is the voltage, but current is different in those two components. We are supposed to uh, draw a voltmeter to measure the voltage of a resistor S. So which means that when you are drawing a voltmeter, remember voltmeter is a high resistor, a high resistance device. So it has to be drawn in such a way that it's parallel to the component. So which means whenever you see a question telling you to add a voltmeter, you need to add it parallel in such a way that I've drawn at that given point. So we need to move right down here. We already wrote what current in ammeter A is, ammeter 1, and also we wrote in ammeter 2 what the current should be is 0.06 amperes in that case. Explain how the voltage across resistor R compare with the voltage across the battery. So we are going to say that the voltage is actually the same. All right, not before that. We are supposed to work out, calculate the voltage across resistor R. Remember, voltage is equals to current times resistance, and we're going to now substitute that because we're given the resistance is 11 and the current is 0.4. So meaning that is 0.4 times 11, which is going to give us 4.4 volts across resistor R. I believe you are getting value from Proflan YouTube channel. And if that is the case, leave a comment down below if this video was helpful. And once you do your exam, please come back and say, leave a comment whether some of the concept that we have dealt with in this particular video featured in your main exam, so that I'll know what again to prepare on for your physics paper 2 that is going to be coming in a few days after you have done your paper 1. Now, we're supposed to explain how the voltage across resistor R compared with the voltage across the battery, and you're gonna realize that since they are, both of them are parallel to each other and there is no another resistive component, then they are going to have the same voltage. So that's why we're saying voltage across resistor R is the same as the voltage across the battery, because they are both parallel and there is no other resistive device in the loop of the two components. Without wasting much time, we need to move to part B. We are told that diagram 2 shows different circuit containing battery, an ammeter, and a thermistor. Remember, a thermistor is a device that whose resistance depends on, or whose resistance is affected by the change in temperature. So meaning that if a resistance, remember in a circuit, if resistance increases, current decreases. If resistance decreases, current increases. So you need to identify the resistance of the thermistor, vary with temperature. So when temperature change, resistance also change, and this is going to affect the amount of current that is going to flow in the circuit. All right, so we need to move down to the next area and next component question, so that we can be able to see what is in store for us. In question number 5, this question is about pressure, and then we are told that describe the method you will use to find the pressure a person exerts on the ground when standing on 2 feet. So remember, for you to work out pressure of a solid is force over area. So we need to know the force the person exerts and also the area in contact with the ground. So I try to highlight a few steps because the foot is quite irregular in shape. So we are going to draw the outline of the foot of this man, so that on a piece of paper, so that we can be able to count the number of squares. So we'll count the number of squares that outline is going to consume, and then we work out the area of 1 square times the number of squares that we shall be having there. So the next thing also, after we have obtained the area, we are going to measure the mass of all the weight, or the weight of this person using a spring balance, so that we can be able to know the force this person exerts. Then from there, we need to use the formula pressure equals to force over area in order to work out the pressure exerted by this man. Now, the total area of contact of the camel's feet with the ground is 1,300 centimeters square, and the mass of the camel is 660 grams. Ah, wow, 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 wow. That is serious. That is an international crisis. How can I say grams a camel, surely? All right, so now after that shock of a camel weighing grams, now I decided I had to take a break so that we can be able to go back and calculate the pressure this camel exerts. Now remember, for us to calculate the pressure the camel exerts, we need to know the force, and the force is actually going to be the weight of this camel. And then remember, force equals to the weight, and the weight is mass times gravity, and is going to be equivalent to 6,600 newtons. And then we told the area is 1,300, so meaning that we can be able to apply the formula that we measured on the upper part and work out the pressure, and that's going to be 5.08 newton per centimeter square as the pressure the camel exerts. A question to do with electromagnetic induction, and we have a coil wire W XYZ positioned between the opposite poles of a magnet. And remember, when current flows through this coil, a force is going to be the coil is going to experience a force. And the reason as to why that force is experienced is because when current flows through a conductor, there is magnetic fields which are created around that conductor. So meaning those magnetic fields which are created around the conductor are going to interact with the magnetic fields of the permanent magnet. Now these are the magnetic fields of the permanent magnet, which are going to interact with the fields created around the wire due to the flow of current. So you have to take note of that. So this part will experience an upward force. XW will experience an upward force, while YZ will experience a downward force. So then the coil is going to have experience a rotational kind of motion. Now we're supposed to explain the motion of the coil of wire, and we need to refer to the magnetic fields. I've already mentioned that when current flows through a wire, the current flows through a wire, magnetic fields are created around the wire due to the flow of current. Then once those magnetic fields, which are created by the flow of current, interact with the magnetic fields of the permanent magnet, then the coil is going now to experience a force. Right? So we have mentioned when current flows through the coil, magnetic fields are created around the coil. The created magnetic fields are going to interact with the magnetic fields of the permanent magnet, and that is why a force is experienced. Remember, when two magnets are brought together, close together, there is a repulsive or attractive force, and this is due to the presence of different fields which are interacting. So the created magnetic fields interact with the fields of the permanent magnet, and producing force the force producing a force on the coil, and the force produced acts in opposite direction in opposite sides of the coil. So each part of the coil is going to experience an opposite force, and for that reason, since the force is acting in opposite direction, then for that reason there is a rotational motion. So the coil is going to rotate. So once the two forces are acting in the opposite side of the coil, then the coil is going to rotate. Explain how the motion of the coil will change if the current is increased. When you increase the current, the force also increases because the fields which are produced become more stronger, so the force is greater, so the coil is going to rotate faster. So if you are going to be asked aspects and different ways you can be able to modify that device so that you can have a greater speed of rotation, you need to use a thicker wire, or you can be able to use more number of turns, or increase the strength of the magnet, or increase the amount of current. Question number 7. This is a question whereby we are told a material is stretched by applying an increasing load, and then we are supposed to describe what's meant by elastic behavior. Different materials stretch, and when the force is released, then those materials go to their original shape and size. And basically, that's what we're going to say. This is a material. This is when materials return to their original size and shape when the force stretching force is released. Then if a material obeys Hooke's law, then that's the kind of graph you're gonna have. But if a material does not obey Hooke's law, for instance, if we are talking of a rubber band, it behave like that. So in this question, we're supposed to draw for a material that obeys Hooke's law. I can see also current is featuring again. Maybe actually this is a different concept on current, and I decided to bring it here intentionally and deliberately so that you can be able to learn something new also in this particular question. We are given a voltage of 1.6 volts, and then we are having two components down here, and these two components are actually in series. So if they are in series, we are going to realize that what is going to be the same in the two components which are in series is the current, but the voltage is going to be different. From the previous question, we say that what's the same in two components which are in parallel is the voltage, but current is different. So this is the opposite of the question that we have done before. So if you don't remember exactly what we said, you need to go back there and get to see what we really focused on. So we need to go on and get to start off in this particular question. Yeah, so we are told that state the formula linking voltage, current, and resistance. So we're going to first say that voltage is equals to current times resistance. We are supposed to calculate the current in the 19 ohm resistor. So we know the voltage, we know the resistance. Then in order to work out the current, we are going to rearrange the formula in order to get it. So this is actually 1.6 divided by 19, which is going to translate to 0.8 watts. Let's try to work it out. Can you confirm using your calculator what you're gonna get there, so that we can be able to proceed the next question? All right, so that is what we are supposed to get in that particular part. So we are supposed to work out the voltage in component X if the voltage in this 16 ohm resistor is 0.91. What is the voltage in X? So you need to realize that if you add the voltage in component X plus the voltage in the 16 ohm resistor, it must give us 1.6. So that's only what you are supposed to do, because we said voltage are different in components which are in series. So we're going to work out that voltage there, 0.91 subtracted from 1.6, and that's going to translate to what? This is going to translate to 0.69 volts. Question number 10, or rather question number 9, answer the questions with a cross in the box. Then you are told a student investigate 4 cars P, Q, R, and S. How is energy transferred usefully from the engine of a car to its wheels? We are going to say that is mechanically, because there are some parts involved. There's some movement of parts involved, so that is mechanically. That is mechanically. So we can be able to say the answer is D. The answer is D in that case. The engine of the car burns petrol, which transfer energy usefully from chemical store of the petrol of the to the kinetic store of the car. The useful power output of car P's engine is 47 kilowatts. We're supposed to calculate the useful energy output. Remember, energy equals to power times time. That's the formula we're going to use in order to work out this particular question. Energy is power times time. So we're going to multiply the power. Remember, it's 47 kilowatts, and the kilowatts in physics, or K means 1000, so it has to be 47,000. You don't forget that. And we are given time in minutes, so it has to be converted in seconds, so that we can be able to work out our answer, and our answer will be given our answer will be given like that, like that, like that, like that, like that. In standard form, we can be able to say this is 4.23 times 10 raised to power 7 joules of useful energy output. The formula, state the formula linking efficiency, useful work energy output, and total energy output. So efficiency equals to useful energy output divided by the total energy output times 100, and we can be able to work it out now. In this case, of course, we had gotten this value, and then we're going to divide by the output energy times 100, and that's going to translate to 21.15%. So as much as you are preparing for your exams, remember this kind of concept. Remember to do questions with work done, power, and efficiency. You need to know how to work out potential energy. You need to know how to work kinetic energy, and energy transfers involved. So that will really make you at a very, very great position. And if you revise all those concepts, it means you'll be at the pivotal point of passing. Moving to part C, then we are told the student extends her investigation by collecting data for car P, Q, R, and S, and she recorded the useful power output of their engines, their masses, and their maximum speed. We have car P, Q, R, and S. We have their corresponding energy, engine useful power output in kilowatts. We are given their masses, and then we have the maximum speed that was can be traveled by the car. Then we're supposed to use the information from the table to discuss the relationship between useful power output, mass, and maximum speed. So if you look at the engine useful power output, it means if the power output is high, the maximum speed also must be high. If the mass is higher, the maximum speed is also higher. Also, if the output, if the mass in kg is higher, then also the engine useful output is higher. So let me just try to highlight all that I've tried to look from the table, and so that we can be able to proceed the next question. I want us to take the minimum time possible to go through this paper, but understanding is also compulsory, so that by the time you come to the end of this video, you have learned something. All right, let's see how fast it will have gone. All right, so we can now start by looking at the first statement. As power increases, maximum speed also increases. So you are going to support your answer by giving an example. You can see now, as the speed, the power increases, the speed also increases. We can also talk of the mass and the speed, trying to compare them. We can also see, as mass also increases, the maximum speed also increases. Yeah, so you can also give an example on the same. Another concept is comparing engine power output and also with the mass. So that also will give you some mark on that. Another concept that is very common, and that is commonly tested, is the working of a loudspeaker. How does a loudspeaker work? Remember, the loudspeaker worked in the concept of electromagnetic. Is actually an electromagnet, and then we have electromagnetic induction involved. So which means that when AC current flows through the coil, then magnetic fields are created, and the magnetic fields that are created are changing in size and direction. So these fields are going to interact with the fields of the permanent magnet, and this is going to make now the tube that is attached to the coil to vibrate. And remember, since the tube is also connected to the peppercorn, once the tube vibrates, the peppercorn also vibrates, and this results to the production of sound. Because we learned that sound is only going to be produced if a material or an object is vibrating. So we're going to say, when current flows through the coil, through the coil, and the current that we're talking about is AC current. When AC current flows through the coil, it creates magnetic fields which are constantly changing in size and direction. Create magnetic fields which are constantly changing in size and direction. These fields which are created, the created magnetic fields are going to interact with the magnetic fields, with the fields of the permanent magnet, and as a result, this is going to result to a force. Yeah, this is going to result to a force when the magnetic fields which are created by the flow of current interact the magnetic field of the permanent magnet. A force which is constantly changing in size and direction is also going to be produced, and this makes the tube to vibrate, as well as the peppercorn vibrates, thus producing a sound. That is how you are supposed to explain how a loudspeaker works. Let's change a gear and look at the concept of electromagnetic spectrum. Remember electromagnetic spectrum. Remember electromagnetic spectrum is a family of waves which are arranged in the order of increasing frequency or decreasing wavelength. So you remember that when we were discussing about electromagnetic waves, we started by looking at what are the waves, what are the main type of waves, what are the main type of waves which make part of the electromagnetic spectrum. We said that we are going to start with radio waves and we end with gamma rays. Now, gamma rays have the highest frequency and the shortest wavelength. But radio waves on the other extreme end have the longest wavelength and the least frequency. Then we went ahead to talk about the common properties of the waves in the electromagnetic spectrum. We said both all of them, they transfer energy. All of them, they obey the wave equation. All of them travel at the speed of light in a vacuum. All of them can be reflected, can be reflected, and can be diffracted. And we did agree that, or if you are asked a question to do with the difference between the waves, common difference between the waves in the electromagnetic spectrum, you are going to base your answer on the difference in frequency and wavelength. Don't start giving differences in terms of the use. We spoke against that, and we said if you are asked the difference between radio waves and microwaves, you are going to base your answer in terms of difference in frequency and wavelength, because you're gonna say maybe radio waves has a longer wavelength while microwaves have a shorter wavelength, right? We went ahead also to talk about different uses of each of the waves in the electromagnetic spectrum. We say that some are used for communication, for instance, visible light, which is used in the optical fibers, and also radio waves, which are used in radio and TV signals transmission. We also talked about microwaves, other waves like microwaves used in cooking, and also infrared used in cooking. We talked of infrared radiation used in infrared cameras, which can be able to take pictures even when it is very, very, very dark. We also talked about the medical use of X-rays and gamma rays. We said X-rays can be used in hospitals for checking the fractures of bones. And we also say that X-rays can be used in industry to check the structure of metals, whether metals have cracks. And also they are used in security checks in the airports and so forth. We also talked about gamma rays, and gamma rays, we say they can be used for food preservation and also sterilization of medical equipment. So you don't forget that gamma rays are also used in treatment of cancer. We also went ahead to talk about the harmful effect of all these radiations. We say the microwaves can cause internal heating of body tissues. We talked about IR, infrared radiations, can cause skin burns. We talked of UV radiations, which can cause skin cancer. We talked of X-rays and gamma rays, which can lead to cancer because they can be able to change the genetic makeup and cause mutation of cells, and which will result to cancer. So that's just a summary of what electromagnetic spectrum topic is all about. Let us be able to check and see what are we asked here. We're supposed to state the wavelength of microwaves. And remember, wavelength from waves is the distance between two successive crests or two successive troughs. So the wavelength is here. So we need to check from the scale. This point is 7, this point is 19. So meaning if we subtract that, we're going to get 12 centimeters, and that becomes our wavelength in centimeters. Then we're supposed to show that the speed of microwave is about 3 times 10 to the power 8, and this is actually the speed of light. So which means that we can be able to use the wave equation, because we said all the waves in the electromagnetic spectrum obeys the wave equation. So if we go ahead and look at this, we're going to see you have to convert also this particular part here. You have to convert it into meters because it was given centimeters. So if you work it out, you're going to get 2 point what? 2 point something 8 watt. Yeah, so which is actually an approximation of 3 meter per second times 10 raised to power 8. We say that X-rays actually can cause internal heating of body tissues. We move to question number 12, whereby we are told that A teacher investigates the penetrating ability of gamma rays from a gamma source, and this is the teacher's method. Place the gamma source at the distance of 25 centimeters from the radiation detector. Place 1 centimeter thick of absorbing material between the source. Measure the radiation count from the source for a time period of 3 seconds. 3 seconds is too small to detect, but it could have even used a longer period of time. Calculate the count rate in the count per second. Repeat the measure of 2 more times. 2 more times too low. The teacher should repeat more and increase the time span over which is going to measure the count rate for accuracy purposes. Then you are supposed to state the suitable radiation detector that the teacher could use, and this is the GM tube. The GM tube is the best. The Geiger Muller tube is the best one. State the independent variable in this case. In the independent variable is the count, is the absorbing material, rather is the absorbing material is the independent variable here. Explain why the absorbing material used in the investigation has a thickness of 1 centimeters. Remember, thickness also affects the absorbing rate. So meaning that if you use a different value, is going to affect the result. And you can say this because thickness also affects the count. So to ensure that the experiment is valid, we are going to control the length, like that, the thickness, so to make the experiment valid. Validity of the experiment. Suggest the improvement the teacher could make to this method. The teacher could, we saw the time was too short, so the teacher could increase the time, could increase the time, or take a count over a long period of time, and also measure the background count. So on the grid, plot a bar chart of the mean count rate for each absorbing material. So we have plastic, copper, wood, aluminum, lead. So we're going to plot all of this on a bar chart. And the reason as to why we're using a bar chart instead of a line graph is because the material is actually a discrete data. Is a discrete data, is not a continuous data. So we have to take account of that. All right, so let us just go straight and work this on the graph and try to see how the bar chart is going to be looking like. If you are new to Proflan YouTube channel, please consider subscribing so that anytime I'm going to upload another series for paper 2, you'll be notified, so that you will be able to you'll be at a position to revise with me, and at the end of the day, this is going to improve your grade. So on the x-axis, we're going to have the absorbing material, and on the y-axis, we're going to have the mean count rate. So I'm going to take that, I move it, and I just move it to this other end. I rotate it so that it can be able to fit in this space that we have provided. So I need to move this one also a little bit here so that we can be able to have our work well arranged, like that. So you need to remember that the axis must be well labeled, and you have to ensure that each part is where it's supposed to be. Then we're going to draw the first one for plastic. Remember, we were given some readings, so we have to fill the scale properly on the y-axis, so that if a best scale is the one that can accommodate all the values that are in the table. So this is the first one, which is actually for plastic, and then we need to move to the next one. Right, so for this is plastic, I need to write it down here. And then the next one is actually copper. Move up to the value that correspond to that, and then we move to, let's see which one we can move to. Wood. Right, wood will just go up to that level. All right, so let me just adjust this. Okay, let me just draw it again. right? So that we can just have it there. Move up to that extent. All right. We need to move also to aluminium is here. We need to move to another one, which is this is what? Okay, let's see. This move, and the last one is let me just write this: lead. This is glass. This is glass, and the last one is going to up to that point. And right, this is now. Let me just move this a little bit. The last one is what? Now the bar chart. Why is a bar chart the correct way to display this result? This is because absorbing material is not a continuous variable, so there is no way we could be able to use a line graph in that case. All right, moving to the next part. A student concludes that the plastic is the best absorber. That's not true. The student is actually wrong, because if you look at we are going to say that the student's his conclusion is actually wrong. Is wrong. The conclusion is wrong because the lower the count rate, the better the absorber the material is. So plastic is not, because plastic is displaying the highest count, so meaning it absorbed the least. So we can say the best absorber is actually lead. Question number 13: describe an experiment to investigate the magnetic field pattern around a permanent bar magnet. Now we have different ways we can be able to do this. We can be able to do this using plotting compasses, moving plotting compasses around um, a bar magnet, or we can be able to use ion filings. The way in this part, I'm going to use ion filings because it's an excellent way of performing this experiment. And we're going to put we're going to put a bar magnet on a flat surface, and then on top of the on top of the bar magnet we're going to place a plain paper. Then we shall sprinkle ion filings on the paper and then tap the paper gently, and all the ion filings are going to arrange themselves in a pattern. To demonstrate this, we are going to draw some bar magnet, and then that's my magnet, and on top I have a paper with ion filings, and then I have the ion filings here. Then I have my bar magnet in that, so I'm going to tap that paper, and the ion filings are going to arrange themselves in a pattern. The pattern of the ion filings is going to represent the magnetic field patterns, and whereby we're going to now determine the direction of the magnetic fields using plotting compass. So if you tap the paper, the ion filings are going to arrange themselves in a given pattern, and the pattern that we're talking about is going to represent the magnetic field pattern. The next question, we are told the diagram shows two bar magnets. Complete the diagram to show the magnetic field pattern. Remember, these two poles are actually like poles, so this there's going to be repulsion between the two fields. So there's a region X where there is no effect of the magnetic field pattern, and this is called the neutral point. So the fields, something you need to remember is that the fields should point from the north to the south. So the direction is very, very key when we are talking about the field, the field of the permanent magnet. So remember also that fields never cross each other. Free fields never cross each other. Question next, we are told that the rocket we're supposed to state how the kinetic energy of the rocket changes, because as the rocket burns the fuel, the speed increases, so the kinetic energy store increases. We are also going to state how the gravitational potential energy store of the rocket changes, so it also increases because the rocket is advancing in height. So as the height increases, the gravitational potential energy also increases. All right, so state the name of the force responsible for keeping a fan cube in the orbit, that is gravitational force. And I can see there is another question to do with orbital speed in this part. So once you realize that this question is very common, you need really to prepare on how to do question to do with orbital speed. So you need to remember this is the formula, and the time has to be in seconds, so we are going to get this as the speed. Then energy transfers, the thermal energy transfer and absorption of thermal energy by different surfaces is the question that is featuring in this particular probe. We have one that is shaded white, another one shaded black, and we are supposed to state use the ideas about thermal energy transfer to explain how the temperature of each metal bar changes as the fan cube spins. And you see now, as it spins, the two boxes, the white and the black, are going to be facing the sun, and some other instances are going to be facing on the other side and very far from the sun. So we're supposed to start by saying when the two are facing the sun, remember the sun is producing some radiation, so heat is going to be transferred through radiation to that fan cube. So meaning we're going to talk about absorption of black and shiny surfaces. So we're going to say the temperature of the black is going to be higher than the temperature of the white when they are facing the sun, because black surfaces are good absorbers. So the temperature of the bar, of the black bar, increases, or the temperature of the bars increases when facing the sun. Both of them increases, but we're going to see that that of the black is going to increase faster than the white one, because black surfaces are actually good absorbers, while the white surfaces are poor absorbers. But when now they go on the other side, when they are facing on the other side, the temperature of the black one is going to lose heat quite faster compared to the white one. So we're going to, while facing away from the sun, the temperature of the black surface decreases faster than the white surface, because black surfaces are good emitters, are better emitters of thermal energy, of radiations per se. And you can see the energy transfer that is taking place here is through radiation only. Convection and conduction have no whatsoever responsibility of transferring energy in this kind of space of a vacuum. You need to know also to how to work out question to do with refraction, and we know that refraction is a bending of a wave as it moves from one optical medium to another. So we have light that is entering glass at an angle of 29 degrees, and that ray is going to be diffracted. So I want us to, we are told to determine the angle of refraction, so we are going to measure this angle of refraction below here. So let me just take you straight so that I can be able to use my protractor and I'll be able to measure that. If I can be able to use this protractor, and you can see that this angle is approximately what is approximately, let me just change the color of this one so that you can be able to be in a position to see it properly. And you can see if we check, the angle of refraction is around 19 point something, around 19, right? So that let's go straight and then get to answer that particular question. So let me just move, let me try again. This is approximately 19 degrees, around there. Yeah, around 19. So let us try and the angle down here, angle of refraction, is 19 degrees, this angle here. Then the formula for refractive index is sin I over sin R, so we can be able to substitute it here so that we can be able to work out that value. And you can see if you work it out, you're going to get 1.5 something. Let's see, just put in your calculator, and that is approximately what, 1.5. And remember, refraction has no units because it's a ratio between the sine of angle of incidence and the sine of angle of refraction. So at this given point, I need also to mention the concept of total internal reflection. Total internal reflection occurs when the angle of incidence is in the dense medium is greater than the angle, the critical angle. So you need to know conditions for total internal reflection to take place, and you need also to understand the concept of the critical angle, the formula relating critical angle, and also the refractive index. In this video, I'm not going to focus into that because in the previous videos, I've worked out questions to do with that. Question number 16, second last question. We are told that some of the energy stores in the nuclei of atoms can be used to generate electricity. A nuclear energy fusion power station generate electricity. We're supposed to state the role of the moderator. The moderator actually slows down the neutrons so that they can be able to react with uranium-235. It reduces the kinetic energy for the reaction to take place. Some of the daughter nuclei produced in nuclear fission are highly radioactive and emit high energy neutrons when they decay. Explain which feature of the nuclear fission reactor reduces the risk from these high energy neutrons. And actually, this is actually the thick concrete or the thick lead which absorb all those neutrons. So the thick lead is meant for the absorption and prevent any radiation from getting out. All right, we also have some part like okay, let me see the next question that you were asked here. The daughter nuclei can cause contamination and irradiation. So if you are told to describe the difference between contamination and irradiation, you need to understand these two concepts. Let me use a different example. If we are working in a nuclear plant, a nuclear station, if you have some food in your plate, if some particles fall on those food in your food, some particles of the radioactive substance, some particles fall in food, your food becomes contaminated because now that food will be radioactive. The particles will be in food, it will be giving out radiation, so your food now becomes radioactive. But if in a second scenario, your food is only exposed to radiations, for instance, if you want to preserve food, you will subject that food to radiations. So when you deliberately expose food to radiations, then that food does not become radioactive, but it becomes that's actually what is called irradiation. When you expose a material to radiations, you say that it's irradiated. So let us try to see how we can be able to define that. Contamination. We shall start with contamination. This is when a non-radioactive material comes into contact with radioactive materials. And in this case, the non-radioactive material now become radioactive because the particles are in that material. So irradiation is when radiations, irradiation is when non-radioactive material is exposed to radiations, so that material does not become radioactive. Describe the process of nuclear fission. No, this is nuclear fusion. Nuclear fission is splitting of heavy nucleus. Nuclear fission is the splitting of heavy nucleus to lighter nucleus. But nuclear fusion is the combination, is a process of combining two lighter nuclei under high temperature and pressure to form heavy nuclei, and also this result to loss of mass and release of energy. We're supposed to state where naturally this occurs. This occurs actually in stars. So we need to say this occurs in the core of a star, of the sun or a star. Conditions for required for this nuclear fusion is actually high temperature, and high temperature is meant to increase the kinetic energy of the particles so that they can be able to collide for the fusion process to take place. Another factor is high pressure, and high pressure is meant to make the particles to become closer enough for them to be able to fuse together, and this is meant to overcome the force of repulsion. All right, moving. Oh, we are done. Otherwise, I wish you all the best and the best of luck in your exam. Don't forget to subscribe and also leave a comment down below. I really wish you the best of luck in your exam. Don't forget to come back once you have done your exam to say whether this video was helpful so that we can also prepare the next series. Thank you. See you in another video.